Hello, everyone. This is the lecture for section 3.6, the chain rule. Okay, so just to recap, section 3.1, 3.2, we learned about how to define the derivative, how to construct it, got a formula for it. 3.3 was the first set of shortcuts to find the derivative. 3.4, we applied at least the basics to some real life physical science, right, and some natural science. 3.5, we learned a couple more shortcuts, right? Specifically for trig functions. 3.6 is the last big derivative rule, the chain rule, okay? Like I said, all of these are sort of shortcuts to make finding the derivative a quicker process so that we don't have to go through the limit definition of the derivative, okay? So the chain rule really does have to do mostly with composite functions when you have a function inside a function, okay? How do you take the derivative of those? This will really open up sort of the amount of functions that we can now handle. With the chain rule, we can now take the derivative of anything we get thrown at, okay? So the first thing I want to do is I want to go ahead and define one thing for those of you who don't remember from high school pre-calc, is the idea of a composite function, okay? So let's say you have f and g that are functions, and h of x is equal to f compose g, or g inside of f of x, right? That is what we call the composition of f and g, okay? So now let's get into the chain rule. So the chain rule, suppose that you have an f of x and a g of x being functions, right? Then for all the x in the domain of g, for which g of x is differentiable at x, and f is differentiable at g of x, okay, then the derivative of the composite function, right, is given by this formula right here, okay? I want to dissect this a little bit because it's a little bit easier. This is in mathematical jargon. Let's go ahead and dissect it a little bit, okay? So I want everyone to look at this right here. Let me go ahead and get rid of the highlighting. I'm going to have everybody look at this right here, that h of x is f of g of x, okay? So if we take a look at how this is defined, right, then what we can see is the f of x, right, the f function, right, is the outside. That is the outside function, right? And g is the inside function, right? Okay. So then when we actually do the derivative right here, okay, look at how this works, okay? I'm going to go ahead and do it this way. Notice that when we want to take the derivative, it's the derivative of the outside function, our f function, right? Leaving the inside untouched, okay? And then it's times afterwards the derivative of the inside, okay? So this is the way that the chain rule works. It's going to be the derivative of the outside, leaving the inside alone, and then taking the derivative of the inside and multiplying them both together, okay? So how does this work out? Let's go ahead and take a look at this very first example right here, okay? Otherwise, without the chain rule, we'd have to actually multiply this out and get an answer that way, right? But the chain rule makes it much faster, okay? So here's how it works. So the outside function, right, that is going to be the stuff for the seventh, okay? The inside function is going to be the 3x cubed plus 2x plus 1. Okay, so we have our inside and we have our outside. Now, the idea here, let me go ahead and do this because I kind of like doing this. I'm going to blotch this all out. So when I want to do the derivative of the outside, leaving the inside alone, I just want to take the derivative of something that's to the seventh power. Okay. And the derivative of that, if you guys remember, this is the easy rule that we were doing maybe in section 3.3, right? That's just going to be something that looks like this. So our f prime, I'm already going to go ahead and start to construct this, is equal to the derivative of something to the 7th power is going to be 7 times the something to the 6th, right? So now remember how our definition goes. The inside remains untouched. The inside was just the 3x cubed plus 2x plus 1. So that's the very first portion. So what we did just here, this right here is this bit right here. Okay, so now we get to do the next bit. Okay, and if so, that means we need to take the derivative of this thing right here, the 3x cubed plus 2x plus 1. And that we get to use our good old, the shortcuts from section 3.3. That's going to be 9x squared plus 2. And we are done. So then this tail end right here, this right here ends up being this right there. Okay, and we are done. Okay. In terms of work for this, notice how I overly explained it to you. Eventually, you guys won't need to overly explain it like I did, right? But so long as you give me some semblance of that you're sort of denoting the inside function and denoting the outside function, I'm more than okay with that, okay? What comes up next is quick checks. So go ahead and make sure you do the one that, just the problems, just the quick checks that are assigned to your discussion group. So if you're group 1, you only have to do group 1. Okay. If you're group 4, you only have to do group 4. Okay. Okay. So let's go ahead and move on. So with the chain rule now, okay, we can go ahead and now sort of combine all these different differentiation rules and really take derivatives of whatever the hell we want now. Okay. Which means you're going to need to keep a track of all of your derivatives. Okay. And that's going to be very, very difficult. Okay. The way that I like to do it is you take the derivatives as you hit them, if that makes any sense. Okay. So as you're proceeding through a derivative problem, right, it's sort of going to tell you what the derivative is that you're going to need to take or what shortcut you're going to need to take. So let me show you guys what I mean by this example right here. Okay. Find the derivative of this following function. Okay. So looking at it before we even start doing anything with it, okay, we see that it's a square root, right, of a division, okay? So when we do the derivative of a square root, we're going to need to require the chain rule, okay? Inside doing that chain rule, inside finalizing, taking the steps of the chain rule, there is a division in there that we're going to have to, so we're going to have to use the quotient rule to take care of that bit, okay? Okay, so now let me show you guys what I mean, okay? Let me sort of put that into action. So I'm going to rewrite this, and this is perfectly fine for anyone to do, right? This can be x over x plus 1 to the 1/2. Now, the way I'm going to do it right now is not entirely required, okay? You can do this probably another different method, right? All of the methods should get you the same answer, okay? So I'm pretty sure maybe some of you guys have already been thinking about this. You can distribute the square root to the top and the bottom, just use quotient rule. That's perfectly fine as well. Okay, I'm just doing it this way to sort of show you the quotient rule and to show you the chain rule, how sort of the different methods can work. Okay, so if we have it written like this, right, we can already see that the outside, outside function is going to be something that is stuck to the 1/2, okay? And then the inside is going to be our x over x plus 1. Okay, so when we need to take the derivative of this, right? We know how to take the derivative of the outside bit. That's our good old regular power rule, right? So this is going to be 1/2 times stuff to the minus 1/2. That's the n minus 1 bit, right? Our inside was x over x plus 1. Okay, now we have a times x over x plus 1. According to chain rule, we now need to take the derivative of this. Okay, and this is what I mean by you do the rule that you need as you hit it. Okay, so in doing the chain rule, right, a quotient rule pops up. So I now need to do this quotient rule on the side. Okay, so then if I have x over x plus 1, let me rewrite that. So this is my high, this is my low. So if my high is x, right, my low is x plus 1, my high prime is equal to 1, my low prime is equal to 1. So then the derivative of this is going to be low, so x plus 1 times d high, which is 1, minus high x times d low, 1, all over the bottom squared. X plus 1 quantity squared. And if you reduce this, you should get 1 over x plus 1 quantity squared. So now, just keep in mind, right? All of this was done by this. This was sort of like a little side piece that I needed to do. So now my final derivative of x is going to be the 1/2 x over x plus 1 minus 1/2 times this mess over here, which was reduced down to 1 over x plus 1 quantity squared. And we are done. That is it. Okay, so notice how quickly we can do derivatives now without needing to go through the limit definition and sort of, looking at these functions, right? We weren't able to do these functions before without the chain rule. So now we can, okay? So now moving on, quick check. I'm making you guys do a bunch of derivatives here, now collapsing a bunch of rules. So now you're going to be doing a chain rule inside of a product rule, or a quotient rule inside of a chain rule. Does that make sense? So make sure you get through them. If you have any questions on them, by all means, come to my drop-in hours, okay? And I believe that is it. This is a short video, okay? So after that is lecture question. If you guys have any questions, like I said, come to my drop-in office hours, drop-in lab hours. I am in person on the at the college if you want to speak to me directly, or we can set up something on the side, some smaller appointment, okay? Besides that, have at it, and I'll see you guys around.